Okay, so we saw in the last segment that we have these orbitals that go in a specific order. 1s, 2s, 2p, so on, so on, so on, so on. I will show you how to commit those to memory in just a moment. What we saw is that we could put these on a Bohr model, okay? And I would encourage you to build this again, okay? Or I could just put it sort of in a row like this. Either way, there's 2 electrons max per orbital, regardless of whether it's an s orbital, a p orbital, or a d orbital. Remember, the orbital is different than a sublevel. Page 11, the order never changes. It's always 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so forth. And we're going to use our periodic table to help us get this order straight. Okay? All right. So we're going to start with the simplest thing in the world, and that's neutral hydrogen. So neutral hydrogen has 1 proton, which means it has 1 electron. Okay, so how many electrons is the first thing you have to do? You have to say, okay, how many electrons do I have to find homes for? So they're going to have to start in 1s. 1s, and there will be 1 electron there. Okay, now my analogous Bohr model is that I will have 1 proton, assuming this is hydrogen 1. I'm going to have n equals 1. I'm going to have the 1s orbital, and I have 1 electron there. That's basically what this is. Okay? Neutral helium. Helium has 2 protons, so 2 electrons. Okay? So we're going to go with helium-4. So we're going to have to start with 1s, and I can only put 2 electrons there. And we're done. Okay? So I've got my 2 protons, 2 neutrons from my nuclide symbol. N equals 1. I have the 1s. And I have 2 electrons there. 1 spins up, 1 spins down. Or I can just write the number 2. They are 2 different ways of basically saying the same thing. Okay? Neutral carbon. I have 6. So let's say carbon 12, okay, 6 electrons, 1s, 2 electrons will go there, 2s comes next, 2 electrons will go there. I start with 6, I've used up 4, now I need 2 more, so those will go in the 2p. 2 plus 2 plus 2 equals 6. Okay, again my Bohr model. 6 protons, 6 neutrons, n equals 1. I have the 1s, and I have 2 electrons there. N equals 2. 2s, I have 2 electrons there. 2p, I have 3 choices. And my rule says I have to fill them 1, 1, 1, and then 1, 2, 3, 4, 5, 6. So I don't make this up. This is just the rule. 1 electron will go here, 1 electron will go there, for a total of 2 electrons, which is what I have there. Okay? Magnesium. Magnesium has a few more, and these are all neutral. And this sets the stage for what we're going to do next. Okay, so we have to know where the electrons are in order to figure out what to do next. Okay? So magnesium, I'll make magnesium 24, 12 electrons, so I'm going to start. 1s, 2 of them are going to go there. 2s, 2 of them are going to go there. 2p, I have 2px, 2py, 2pz. 3 choices times 2, 6 electrons can go there. And now I've used up 2 plus 2 plus 6, or 10 electrons, and I have 2 more left. Okay? 3s, because 3s comes next, and that's where my 2 electrons will go. My Bohr model, 12 protons, 12 neutrons, N equals 1, 2 electrons. N equals 2. I'm just going to draw my Bohr model a little bit different. I have 2 here, plus 6 more here is 8 electrons. N equals 3 is the highest N level where I'm going to find electrons, and how many of them are there? There are 2. And this again is important as we move forward to help us figure out what these atoms are going to do next. Okay? Oxygen. Oxygen has 8. Phosphorus has 15. Okay? So I'll rewrite 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and so forth. That's the order. It always goes in that order. It never changes. Okay? So 1s, I have to start there. 2 electrons. 2s, 2 electrons. 2p, remember, I can have 3 orbitals times 2 is 6, but if I put 6, then that's 10 electrons. I don't have that many. I started with 8, I've used up 4, so only 4 electrons can go there. Okay? Sometimes you see these as what we call energy diagrams, and maybe I should draw that, see if that will help you. 1s, 2s, 2p, 3s, and so forth, just like the Monopoly board. 2 electrons in 1s, 2 electrons in 2s, 1, 2, 3, 4 electrons in 2p, if that's helpful. Otherwise, the Bohr model, oxygen, if we make it oxygen 16, 8 protons, 8 neutrons. By the way, if you've noticed a pattern here that the number of protons are equaling the number of neutrons, and there's a reason for that. Nonetheless, N equals 1 has 2 electrons, N equals 2 has 6 electrons. Okay? And then the last one for this segment will be our phosphorus, which I already determined has 15. So we're just going to keep counting. 1s2, 2s2, 2p6. That's now 10. And we have 5 more. So after 2p is 3s. 2 electrons there. That's the most I can put. 3p. So 2 plus 2 plus 6 plus 2 is 12. I have 3 more, and they're going to end up in the 3p. N equals 1, 2 electrons. N equals 2, 8 electrons. N equals 3, 5. 2 plus 3 is 5 electrons. Okay, now this is going to set the stage for what comes next. Okay, so the next segment will begin on electron configurations.